Page 2 of the fraction tome is divisibility rules. These are rules that you should have learned in elementary school. 1 divides any integer. So like 12 divided by 1 equals 12. 3 divided by 1 equals 3, and so on. For 2's, the last 1 digit is divisible. So we have a number and then we have the last digit. That last digit has to either be 0, 2, 4, 6, or 8. So it ends with one of those numbers. It doesn't matter what comes before that, as long as the ones place has one of those even numbers. For 3, the sum of the digits are divisible. For example, if we had 12, 1 plus 2 equals 3, and 3 divides by 3. You could have another number like 171, and that would be 1 plus 7 plus 1. That's 9, and 9 divides by 3. So 3 would also go into 171. You can also check that with the calculator. It's 57 in that case. For 4, the last 2 digits need to be divisible. So it's the last 2 digits. If you want to find all those numbers, it would be from 0 to 96. All multiples of 4 from 0 to 96. See if you can find all of those. For 5, the number either ends in a 0 or a 5. And then for 6, it needs to be divisible by 2 and 3. If it's divisible by both 2 and 3, it's also divisible by 6. Now, for 7's, you're going to minus double the ones place and see if that's divisible. So, for example, if we had 63, you would minus doubles the ones place. So double the ones place would be 6. And if you subtracted those, you would get 0, and 0 does divide by 7. Another example, we could have 91. If we doubled 1, we get 2. 9 minus 2 would equal 7. 7 divides by 7. If we did 28, we do 2 minus 16, which is negative 14, and that divides by 7 as well. And let's do one more example, 175. So if we double 5, that's 10. So we have 17 minus 10. That equals 7. That divides by 7. So this one works. 7 is the harder one to remember out of these. And to remember, you can also use a calculator if given one to see if they're divisible. And then 8, instead of 4 for last 2 and 2 for last 1, now the last 3 digits need to be divisible. So you'd write all the multiples of 8 from 0 to 992 if you want to see all the possibilities for this to work. And then for 9's, it's just like 3's, the sum of the digits has to be divisible. So the sum of the digits has to be eventually either 9 or 0. So like we have 18, 1 plus 8 is 9, 27, that would be 9. If we had a number like 567, it'd be 5 plus 6 plus 7, that's 18. And if you did it again, you get 9, so that works. And then for 10's, the number has to end in a 0. So finish making the extra notes on this page and then move on to the next page.